Hello and welcome to my second lecture on Introduction to Biostatistics. If you note on top it says Lecture 2A, that means the second lecture in Introduction to Biostatistics will have different parts, actually three parts, and each of the parts will focus on one specific concept in details. So let's start with variables, which is a very essential component of biostatistics itself. So before that, let's recapitulate a little bit of what we discussed in our first lecture, which discussed about, gave an overview of the relevant concepts to biostatistics. But also, you'll see that the reason do a little bit of recapitulation before going to the next new lecture is because we will see how the topic in this lecture ties up with the topic in the previous lecture. So, what did we talk previous lecture? We talked about research questions, the different types of research, and that in research you need to operationalize whatever you're going to measure. Of course, the measurement implies that it's a numerical data and is an essential component of quantitative research itself. And like I said, it needs to be measurable. It's collected using an instrument or data collection tool, and ensuring reliability and validity is an important thing, right? So we'll discuss about those in details in due time, but I just wanted to tell you that the second this lecture 2A and 2B will really aim to discuss concepts that relate to all of this above. All of this above meaning this discussions about relevant discussion about research that we did in our first lecture. Okay, so that's what you need to mind. In lecture 2A, we're going to talk about variables, and in lecture 2B, we'll talk about data nature of the data, and all this tying up to research question as well as biostatistics. Okay, so the objective of this today's question, again, you'll be able to answer what is a variable, what are the different kinds of variables, why is it important to categorize variables, and how is the concept of variable really related to previous discussion and research question. And like I said, I will actually keep on tying up concepts of the previous and the new ones, and start to show you the comprehensive picture, the circular picture of the entire biostatistics and research. And they actually really relate to each other. So it's one way it's not so easy to even separately discuss them. Things keep coming up, so you need to bear with me sometimes about research method, because that really demands a separate course and discussion. But I will, of course, briefly keep on telling you about the relevant concepts of research in biostatistics as well. Just to tell you again, just like in the first lecture, I told you that my course on biostatistics, I usually tell my students that by the end of the course, they should be um, um, uh, they should be able to say that biostatistics is fun and I can speak in the language of statistics. But also I do some required for my course thing, and I say to my students that do not be afraid of any statistical terms. So for example, variables itself is a statistical term that people use, but you later on realize, and not only this, but also other terms, that they are not really something to be afraid of. Because remember that all these words are really English words. So I would say majority of biostatistical or any discipline terms are really borrowed from English, and they apply it some way in a customized way for their own discipline. So that's the point. To consider any term you see in my lecture or statistic books as well in English first. Consider the exact literal meaning of that word in English, if you read it in English, of course. um, and then try to understand the meaning of that word in English using its literal sense, what it really means. I will show you an example with this particular topics variable itself. um, then keep relating. That's another thing that you need to do in my course, is keep relating previous concepts with the current one, because remember, biostatistics is just one single picture. It's not, although we different topics, of course you have to do that in different sessions, but keep relating with what you learned before and what you learn new, and see the connection. Why is it needed? Okay. And it makes a perfect sense. You'll see that. So let's begin with variable, right? Just the word itself, variable. Yeah. Okay. So just the word itself, variable. Think in English first. Like I said, that's not only required for my course, but if you read any books, any statistics book or any research method books, any discipline really, think of the word in English. Variable is a simple breakdown of the word able to vary, right? It's, to this kind of two parts, vary and able, and you could just make a sense out of that. It's something probably able to vary. But in statistics, the way they would use it is say that a characteristic that can take more than one attribute or value. So you have a variable, and I'm saying that it's able to vary. What that means is, it can take different values, because in statistics, remember, so this is how you relate concept. In statistics, we talk about numerical things, numbers, counts. So variable that can take on different kind of values, meaning that they can actually take different kind of numbers. And we'll see examples of how that's done, right? And almost everything we see around or perceive around us can be considered variable, right? Because think about, just close your eyes or open your eyes, whatever, and think about anything, and you will see that they will vary. Except there is an exception, of course, like constants. Constants cannot vary. They are fixed numbers, right? So a 2 is a 2 everywhere in the universe, although philosophically there's debate about that. But a 2 should be a 2 everywhere. You don't really say that a 2 is different in planet Mars, or a 2 is different beside the Amazon jungle or something. But it's all same. That's a constant, and it's really the opposite concept of a variable. But if you say, I'll give an examples of variables. For example, gender, right, is a variable, since it can be either male or female. And now they're thinking about a transgender, a third gender, not a transgender, really, a third gender. So I should actually put it in there. But also, people sometimes tend to not identify themselves as in gender. That's a different discussion. But in general, in the societal system that we have so far, a gender can take in the majority of time a male or a female role. I'm not talking about, remember, I'm not talking about biological sexual identity. I'm talking about gender itself, male or female, or even the third gender in between. So it can vary. So what that means, I'll tell you a little bit later also. What do you mean by varying male? A male can be a female can be a male. It's not really that. But when we say the word gender, and we know that this characteristics of human being is different from person to person, we're saying that it's taking different values for person to person. And then we have age, for example, is a variable, since people's age can vary, right? And different people have different age. So you go into a group of people, and then you start finding different age people, different age categories as well. So the word age, or the concept age itself, is variable because it takes on varying numbers for different individuals. Now, if you, of course, on a given period of on a given point of time, a lot of individuals are born in this planet Earth, and all of their age is the same. But we're not talking about that kind of thing. We're talking about things that it is able to vary, even though you may have the same age for many different people. It can take different values for other people, as opposed to a constant. It can't do that. So there are more variables. For example, time, it changes, and we measure it in hours, minutes, years, months, whatever you want to measure it in. And then you have disease status is a variable. Why? Because some people are ill and some are not ill. So you can have two status of disease for an individual. So it's a variable, disease status. You can have occupation, for example, as a variable. Why? Because different people have different occupations. And then blood pressure, it can be 180 millimeter for mercury, if it's a systolic or even a diastolic, whatever, it's a high blood pressure. So you can say, high blood pressure, low blood pressure, or you can actually measure the blood pressure in different numerical numbers. Now you may ask questions about, wait a minute, I can measure time in numbers, years, hours, minutes, and seconds. But disease stages, ill or not ill, how do you do a numerical attribute or numerical measurement of this variable disease status? Well, you actually don't do it directly. You code them. You say ill is coded as 1 and not ill is coded as 0. Then you count how many people are ill. Then you have like 20 people ill, and you count how many people are not ill, and you have 30 people not ill, and so you have 20 ones and then 30 zeros. Okay, so in quantitative research, remember, and we'll talk about qualitative data as well a little bit, uh, qualitative variable, I'm sorry, qualitative or categorical variable a little bit, and they say only the quality and category of things, but we need to have a way of measuring them, putting numbers on them. Otherwise we can't really do quantitative data analysis with those things. The same case with occupation. You may have numbers of occupation, and what in there, how do you make sense of them in terms of numerical counts? Well, you put numbers on them, you code them, and then count how many. So that's really a straightforward and very easy and simple thing. Even school children do that. But with blood pressure, you may have numbers, but you can also categorize after a cutoff point of, let's say, 120 millimeter mercury being the normal or standard for systolic blood pressure. Anything above that, you can say it's a high blood pressure if you want. But then high blood pressure, again, it's not a number, so you have to code that as a number. You have to say high blood pressure equals 1, moderate blood pressure equals 2, low blood pressure equals 3 or something. More with that. So you have lipid concentration, blood lipid concentration, measured in gram per deciliter. It's a variable. It changes from people to people, even time to time in individual person. Then you have the income, right? It's a variable. Different people may have different kind of income. So the concept of income is able to vary from different person to person. The temperature as well, and then drug compliance or adherence. Some person, an individual may have an excellent, or someone else may have a moderate or unacceptable drug compliance, adherence to drug, or it could just be yes drug compliance and no drug compliance, and but they would all need to be, as you can see, coded, because they're not inherently they're not numerical, right? So you don't measure them with a number straightforward. So they need to be coded, and we'll see later, of course, how that's done. So what is not a variable? Well, any constant or characteristic that cannot take any other value, right? All numbers, digits that you're looking at are not variable. They're constants. So you say, blood pressure 120 millimeter mercury. That 120 millimeter mercury is not a variable. That's constant. But the concept of a blood pressure is a variable. More examples of constant could be, gravitational constant itself. We all know that. We've learned that in our schools. Of course, for a specific planet, that's very much a constant thing. And then if you think about even gravitational constant, G for Earth, that's okay, 9.8 meter per second square. But go to another planet, for example, Jupiter, that's actually 12 times more. So that's varying from planet to planet. So considering the universal concept of gravitation, that may be actually a variable, okay, but not for a specific planet. And then you have a dissociation constant called a pK for any given reaction, right? It kind of tells you the rate and direction of a chemical reaction where the molecules will dissociate from each other, at what rate, and depends on the the chemical environment of that reaction. So that's really a constant for specific reactions. So that's why it's called a constant. But again, these two examples are a little tricky, because it's not really telling you straightforward, like, well, what about another reaction? The pK is different. Another reaction, pK is different. But what we're trying to say is, for a specific reaction, it is constant. Okay, it's constant and not a variable. On what is data, although we talk about this thing more later on. But data are analyzable and specific characteristics of any variable or theme. We need to say this a little bit here, although we'll have much more discussion, is because when we're saying variable, and then we're also giving examples of numbers that are constant. So those numbers that are given to that variable for individual sources, and by individual sources we mean like an individual person or maybe an individual institution, whatever we're doing the research on, you have a unit of analysis, and that unit of analysis gives you the numbers for the variable. So I may be a unit of analysis and you're measuring blood pressure, and my blood pressure that you're measuring is a variable because it can take different values for different persons or even me in different times of the day. And whatever measurement you're having for the blood pressure variable is a number like a 120 millimeter mercury, and that's your data. So this data itself is analyzable. It has specific characteristics. It gives a specific characteristics of any variable or value. But the corresponding thing in what you call qualitative research is theme. So in qualitative research, we don't say variable, we say themes. In quantitative research, when we obtain values for any variable, we typically get a data. That's what we're saying. We measure it and then we get a data. Example of data would be, weighing, which is, I'm sorry, this should be weighing time, waiting time. That's the wrong spelling. Waiting time in of 3 different clinics, for example, could be 30 minutes, 20 minutes, 27 minutes. Each is a datum. So 30 minutes is a datum, 20 minutes, 25 minutes is a datum. So that's a singular for data, but we never use, I mean, I haven't seen anywhere you use the singular noun, but it's just good to remember that data is really a plural. We always have more than one. That's why you call it data. But if you have a single datum to talk about, that's what you have to use. And qualitative data are in words, like we said in our previous lecture. I like the red tablets. They're not bitter. So, red is an attribute, bitter is another attribute, and these are themes, not really. I'm sorry. These are the theme here is choice for tablets, and the data, for example, are in words: red, bitter. So the choice is towards red tablet, and the choice against is bitter tablets. So the choice here is the variable taking data with words. That's qualitative research. Now let's relate how variable and data is, how they go together. Okay, so when variables begin to receive numerical information from and about individual source, they become data. Just we've talked about that. For example, BMI, the body mass index, is a variable. For person to person it's different. If we measured this for different individuals, it's going to give us different numbers. Even for the same individual, that could be. And note that BMI does not have a unit, so it could be 30. I'm sorry, BMI has units. Why did I say that? BMI has units. It's the way you measure it, uh, weight over kilogram per meter square of body area, right? So 30, but then they don't really mention it in when they have scales for BMI to compare different persons' BMI. They're not going to mention the units anymore because it's all the same. So it's 30, 28, 23, and note that these are specific constant numbers. These are not variables. These are data. These are data that are numerical measurements of the BMI variable. Okay, so variable to data. That's the point. You have variables. You're kind of trying to measure that in a numerical form, and then what you measure, the number that you get, are giving you data. All right. So what are the different kinds of variables? Right? So in statistics, variables can be classified in many different ways, really. So we can have, according to the nature of it, and then you can have according to study designs sometimes. You can have, according to nature, you can have qualitative variables. Okay? Color, hardness, shape. And you have to really pay attention to something. By qualitative variables, in quantitative research, we don't really mean qualitative research themes in here. Okay, what we are saying is that these variables, the data that you get from these variables, is not in numbers, it's in words, and that's why we're calling it qualitative variables. I mean, this is one way of calling it. People call it qualitative variable, but it, name doesn't really matter. What you're thinking about is, I'm not collecting the data in numbers, I'm collecting them in words, so they are, a quality of something. Now I have to put numbers in there. So if color is a variable, it's a qualitative variable that's not measurable in numbers. I'm going to put numbers here. I'm going to call blue as 1, red as 2, white as 3, black as 4, etc. Hardness, if you know about Morse scale is the scale that measures hardness, right? And hardness variable itself is really not measurable. They have made a scale, and graded it from 1 to, I think, 10, and 1 being talc, the softest thing ever, and then diamond, I think, is on the last one. It's the hardest thing. Okay, shape itself can be a variable, and then the data that you get are not in numbers. You get square shape, round shape. Those are not numbers, but you code them later and then say all the square tablets are coded 1, all the round tablets coded 2, etc. Then we can have quantitative variables, which are measured directly in numbers. Weight is a variable because weight changes from person to person, and you measure it directly in numbers in different units. And then you have, units, that's SI unit, metric unit, empirical unit, whatever unit you talk about. And then you have length in the same way. You have time. You measure them in numbers, minutes, seconds. pH is a variable because it changes from solution to solution. But like pK is a constant for a specific reaction, pH is also constant for specific kind of chemical substance, right? So these are tricky ones, but you could use them as a variable because let's say you're doing a research where a lot of chemical is involved, or even the blood pH has a range, it changes. So it's not always the same, it changes a little bit. So pH could be a variable, but it's measured in numbers. Okay. According to study design, you have dependent or outcome or predicted variable, and then you also have independent predictor or exposure variable. Now, these names that you're seeing here with oblique signs, it means they are all the same things. They're just called differently in different textbooks or situations, but they mean all the same things, and we'll see them in details later. So a dependent variable, we'll discuss what they are, but briefly, a variable that is a result of other variable or variables. So it's dependent on something. It's a result, so it becomes an outcome of something. Okay, it's a predicted variable because it is a result, so it has been predicted. And all these are a little different in names because really you can use them differently, but they all mean the same thing. Then you have independent, right, the opposite. Okay, dependent, you have independent. You have predicted variable, you have predictor variable. You have outcome variable, the opposite is exposure variable. So as a result of the exposure, there's an outcome. As a result of the predictor, which predicts, you have predicted variable. As a result of dependent variable, you have independent variable. As a result of independent variable that makes a change in the dependent variable. Okay, and we'll see them in detail. Let's talk about dependent and independent variables. We first begin with the dependent variable, and here we go. Consider the term again. Okay, again, consider the term in English. What does the word dependent mean? The term dependent implies that the change in the values of this variable is dependent on something else. Simple, right? So a dependent variable must be a variable that's really dependent on something else. If it's dependent on something else, then you're waiting for something else to cause it. And if it's a dependent variable, then it's a result of something else. Something has happened before, and this was dependent, and that's why this one has occurred after that. So for example, well, not the example, first we'll discuss a little bit about what it means. It means something changes. This variable, this dependent variable, is changed by something, and you can see this as a result of the change. The dependent variable is usually seen as a result of the change. Okay. um, Dependent variable is therefore always an effect or an outcome of something, of a cause or an exposure. So you have, I'll give you a very simple example that everyone knows from Newton's first law, right? You push something and that something moves. Okay, the push is your independent variable. The result that you see is that the object is moving, and that movement is your dependent variable because it was dependent on the push. All right, so if you match it with this, then the effect was that something moved. The cause was the push, or the outcome was the fact that it moved, and the exposure was that push. Okay, simple. It's a result that you're watching. Now about variable, again, consider the term. It means liberal. It's unrestricted, free. It works by itself. Okay, you push whatever you like. I mean, however strength you want to push it with, strong, hard, and then accordingly you'll see the movement, fast, slow, whatever. Right. So independent variables are free and do not change their values as a result of an influence. Just you doing it. But I will show you that independent variables can also be dependent sometimes. So like I said, when you push something that's independent, you're willing to push hard, fast, I mean, with a lot of strength, you're seeing the dependent outcome, the move going fast. But also note that the fact that you're wanting to push it very fast or hard is dependent on your desire. So your desire here might be independent. Your desire might be independent, and the hardness of your push, the strength of your push may be dependent, and then as a result, the movement is another dependent. So, but we're not saying that we have two dependents here, really. We're saying that first, this is independent, the desire to push hard, and then when you push it hard already, that's independent for the outcome there. Okay, so it's a cascade of things. But note that they're variables. Independent variables are also variables. They can vary. I can push hard, or I can push slow. But it's the main point is it's not as a result of another variable when you're considering it as an independent variable. But if you consider, no, I have a desire to push hard and that's my independent, well, fine. If that's your independent, then the strength that you pushed it with is going to be your dependent. Okay. And then again, you can say, why do I have the desire? Maybe I have a desire to push it hard because of something else, because maybe the need, and the need now is the independent variable, and the desire is the dependent variable. And then the desire could be an independent variable, and the strength of the push is the dependent variable. The strength of the push is the independent variable, and the result that you see, something moving fast, is your dependent variable. So it's a cascade and depends on the situation of when it's going to be dependent, when it's going to be independent. And that's one of the reasons why I said the dependent and independent categories are based on research design. In some design, a variable could be treated as independent. In another design, in another situation, it could be treated as a dependent variable. Okay, so the bottom line is independent variables influence, cause, or yields dependent variables. That's always happening, and that's one way to identify which one is your independent variable. If you see something is making an effect, that something that is making an effect is your independent variable. It's for beginners, really, sometimes it's difficult to distinguish between dependent and independent variable. Frankly speaking, when I started studying statistics, I had a very hard time differentiating between dependent and independent variables and using it very, very accurately. All right, so let's with an example, and I'll give an example from my MPH thesis that I did in 2005, and the result I got from my thesis is something like this. So different amount of arsenic intake by mothers through drinking contaminated water, that is arsenic contaminated water, changes the arsenic concentration of their breast milk. So these were breastfeeding mothers, and then I mean lactating mothers breastfeeding their children, and I had a curiosity to see, if they're drinking contaminated arsenic contaminated water, do their babies get arsenic through breast milk, because those exclusively breastfed children were not taking water from any other source. But if the breast milk had arsenic in them, then that could be a problem, right? So identify, we have two things here: amount of arsenic intake, and that is resulting, well, that's my hypothesis. Remember, we talked about hypothesis the other day, is that arsenic concentration in breast milk, there is a relationship. That's what I'm assuming. So the amount of arsenic intake should be causing the breast milk arsenic concentration change. So you can already guess which one is the dependent and which one is the independent. The arsenic concentration in breast milk is dependent on the amount of arsenic intake. It's common sense, right? This can be considered as a dose, and this can be considered as a an effect. And so that's your deep independent causing the dependent. Okay, I'll give you another example with my thesis from my master's thesis in early childhood development in 2014. And I found that lack of and this was done in Bangladesh, by the way, urban areas, lack of playing opportunities in schools really creates a disinclination to attend school during early childhood development age. And what are the two things that we have here? So we're looking for dependent and independent variable, okay, common sense. And then we're trying to look for what are the two things that we have here. What is being affected? What is the result? Okay, and what is causing it? So look at it again. Lack of playing opportunity creates, and that's already saying you that this lack of playing opportunity or playing opportunity itself is creating something. So this is going to give that result, and therefore this is not dependent, but it creates the result, disinclination to attend school. So this is the effect that you're looking at, you're saying. So disinclination must be dependent on playing lack of playing opportunity. So that's it. Playing opportunity gives attendance disinclination. I mean lack of playing opportunity. I'm sorry. This should be lack of playing opportunity giving attendance disinclination, and therefore independent and dependent variable. And we can have many other examples. For example, and this is a made-up one: if dose of hypertensive antihypertensive drugs change the blood pressure value change. There are two changes here. If dose of antihypertensive drug change, so we're giving different doses, that's what I mean, is changing the blood pressure value differently, then who is the cause and who is the effect? So who is the dependent, who is the independent, right? So drug is changing the blood pressure. Drug must be independent. What is being changed is your dependence, right? Dose is independent variable, and you have blood pressure as a dependent. Now there is a mathematical thing that you need to know. It's very basic. You probably, people who are from science background already knows this, but those who are not, I'll just explain it very briefly. It's not difficult at all. Dependent variables are usually denoted as y. The reason they're and then of course the independent is denoted as x. The reason they're y and x is because they correspond to the x and y axis in mathematical graphs. In any graph you should have an x and y axis, and the independent variables are always in the x axis. The dependent variable is always on the y axis. Mathematically they have a way of mentioning this. It's called y equals function of x, and when you have a relation like this, it can always be put on a graph in a coordinate system, and it has implication in statistics. We'll see this later. But what does it mean? I mean, mathematical symbols should always be interpreted in English, and this means that with changes in x, y changes, or y is dependent on the change in x. Okay, how does that happen? So if you remember mathematics and a function a little bit, is to some extent pre-calculus, but also algebra by itself. If you have a relation where it says y equals function of x, that means y is functioning as a result of change in s, and that is why you read it y equals function of x, or y is a function of x. Any function that x is performing is giving y a value. That means if you change x to 1, y becomes 1. If you change x to 2, y becomes 2. But there are more complex relationships. I'm just giving you an example. So if that is true, that if you change this is changing, then x must be your independent, and y must be, as a result, you're seeing the result of the change, and that is your dependent. Okay, this is a little important to remember because we'll have a lot of these relevant discussions in statistics. So for example, graphically, would show things like dependent and independent variables in x and y-axis. As I told you, the x-axis corresponds to your independent variable, and the y-axis corresponds to your dependent variable, right? So we were saying that if x changes, then y changes. That's what our claim was. And if that is true, then let's say x starts to change its value here, and the corresponding y starts to change the value up there or whatever. I've just made up a relationship, it's a made up relationship.
Something's not right.
I'm sorry about that. That was my Cortana. Okay, so let's come back. So if the independent variable changes this way, there should be a corresponding change of the dependent variable, and could have many different patterns. So for example, you have, according to the again, the independent variable, the x-axis, the dependent variable, the y-axis. Okay. But what did I have in my what this means is, if you remember, x was here, the previous slide was here. If there was an x here, independent variable was the total amount of arsenic. If you took an x here, the corresponding y change was here, and that made a change, and then it made a graph like this. I'll give you that made an effect on the breast milk arsenic concentration. Usually, normally you shouldn't find that in breast milk, but if someone is taking contaminated water, you may take it. So the graph really look like this. Ignore all the complexities here. This comes at least 10 lectures later. You will be able to understand all of these figures very easily, but right now focus on what's written here. The independent variable is the total amount of arsenic exposure from drinking water, and as this changed to different values in my result, 200, 400, these are the graded results that was spit out by the, of course, the computer statistical software. But as this total amount of arsenic exposure from drinking water in 24 hours changed, so did the values of arsenic concentration in breast milk changed. And these are individual data points here, the asterisk that you're looking at. So if someone had a arsenic concentration intake in drinking water, a mother had taken this amount, then her breast milk had this amount of arsenic. Now you may ask, well, someone was taking a little less arsenic, but how did she have that? And this is what is interesting about statistics and data. You will find variations, and if you did not have variations, there would be even no point in trying to find an answer. If you already knew that everyone would be just, one by one, gradually going up, going up, going up, then you wouldn't do a research anymore. There are variations, and the concept of variation is another very important concept that we will discuss in descriptive statistics later. Just right now, focus on dependent and independent variable, which means that as things change on this direction, the effect or the outcome changes on this direction. And usually in statistical graphical method, we just put a straight line and say this is the relationship. Okay, moving on to quantitative a bit more. So it's kind of like also summarizing. Quantitative variables always yield data in numbers. Remember that, we know that already. Generally, there are two kinds of numbers that quantitative variables can take, generally speaking. Okay, and we will discuss this a little later in when we talk about data exclusively, nature of the data. So the first kind is really called continuous, and again, note the word meaning, continuous variable. Okay, so data that are continuous in nature in quantitative variable is called quantitative variable also. Sorry, continuous variable also. So fractions are allowed here. Okay, because in a continuity you may have fractions. You may have 1 and then 1.15 and then 1.115, 1.125, whatever. So fractions is allowed in a continuous form. We'll talk about this later. But discrete continuous discrete variables, fractions are not allowed. Okay, they're whole numbers. That's the difference. You cannot have fractions in discrete, and that's why the meaning discrete. Examples of continuous variables: the term continuous, non-stop in nature, right? um, it can keep continuing, and from one point to another, one point to another, and then you don't know how many points it's really crossing, or how many points it's beginning and ending with. So just see this line here, uh, and then this yellow line here. Okay, I don't know how to move it back though. Okay, it's not moving back. Anyway, if you've seen this line go from here to here all the way, right? That is how it was formed. But it's interesting. It's interesting. If you want to break up this line into several pieces, how many pieces do you think you can get? Can you guess? Like, you want to break up this line into as many pieces you like. How many pieces will you get? You can't say, because each piece can be broken down to a smaller piece, and then to a smaller piece, and then to a smaller piece, until you get atoms or pixels in here, right? You get so small pieces. Okay, and of course after atom it doesn't exist as a point anymore. So it's almost countless, and that's really the nature of quantitative data or quantitative variable, that this variable that you're measuring can take values that are really able to break down into smaller pieces. Time is a very good example. Even weight or height is a very good example. You can keep measuring. So for example, let's say we say time. Okay, now what is the number of divisions of time between 1 to 3 seconds, for example? You'll say, oh, it's only 3 divisions, 1, 2, and 3 seconds. No, that's discrete. Those are the whole numbers. I can say 1.15 seconds, I can say 1.00005 seconds, and then even smaller, and then smaller. So the fact that it can be broken down into many different parts between two discretes is what is continuous. Okay, so what you will be able to understand this very easily. Look at this. How many numbers are there between 1 and 3? Just like I said. Okay, it can continue as many as we like. You can start, okay, 1 point, blah, a lot of zeros, and then 1.12, and then more, and then with that I may be having zillion or gazillions of numbers between 1 and 3. Okay, and that's the nature of the quantitative. So therefore this kind of variables are continuous. It can keep on going between one point to another. And time, as I said, is a continuous variable. But can you prove it? Well, I've already told you, you can't prove it. The time is a continuous variable, because you have 1 second, 1.1 second, 1.12 second, 1.13 second, 1.14 second. You're measuring that, and it's interesting. If you see, a stopwatch, it really moves on that way, right? Okay, discrete variables. Easy. Discrete is unique, distinct, individual. So discrete variables cannot have a continuous progression. It has to go step by step, cut. Okay, every value is going to be unique. Number of children and households, God forbid, but you cannot have number of continuous children. You cannot have 1.5 children. Although in many research calculations you will see that the average number of children per household is 3.5, and that's just because of a mathematical calculation. It doesn't, you cannot translate it. You cannot translate it for individual household. You can never say that a particular household has 3.5 children. You can say 2 households have at least 7 children. That's fine. Okay, so why is it important to categorize variables? Well, the reason will be more obvious as we discuss, but then statistics often deals with equations. Okay, and equations in the formula, it kind of goes like this for some of the statistical equations, but there are many kinds. It depends how this figure is going to actually look like graphically, or even in a calculation, depends on the nature of the numbers. So you have, y as your dependent, x as your independent. So are these dependent and independent going to be discrete or continuous? If it's continuous, then the calculation goes in one way. If it's discrete, the calculation goes in another way. Those who have done graphs before, that category discrete variables will, it's better to make frequency bar graphs with them, but with continuous variables it's better to make a scatter plot or even a line graph with that, right? So that's how it different. But also, moreover, the equations and formula have different ways of functioning for continuous and discrete data, and that's what I said a little bit later. I think discrete is spelled wrong here. So now I'm going to relate all the previous lecture. I mean, I had only one lecture, but then with this topic very specifically, okay? We talked about, remember, we talked about in our first lecture a lot about research and research question. And the reason we said that it was relevant to biostatistics discussion is because you will see that research question gives you the variable itself, and variable gives you the data. Remember, variable to data. And data is what you analyze in our research, as in our statistics. So they are related, okay? So we talked about research a lot. Now let's talk about research question from, again, from my MPH thesis. My question was, is there any relationship between the amount of arsenic intake through drinking contaminated water and arsenic concentration in breast milk? Those were the two variables that I needed to measure: amount of arsenic intake and arsenic concentration in breast milk. If I had asked a different research question, of course, I would be measuring different variables and I would be getting different data and I would be interpreting different data to answer that research question, right? So your variables will most of the time come from research question. Asking it correctly, therefore, is important, and we discussed that in our first lecture. Um, but remember that the research question is not the only thing that dictates what your variable, I mean, how many variables you'll have. Within the research question, you may have many hidden agenda that people will explore. And that's again a discussion of the research method lecture. But for now, you would need to see the relationship. You have a research question. Within the research question, you have variables. The variables, if you measure them, gives you data, and data is what we analyze in statistics. So that's kind of the relationship, okay? Now let's conclude this by summarizing the concept of variable. It's the most important take-home message that you should be taking is variable is something that can take a variety of numerical values, and that's why they're called variables, not a constant, which is really just as it is. It can be categorized in many different ways. Basically, we've talked about two different ways. And then in research and statistical analysis, the categories are important. Whether it's important because it depends on the nature of these variables, dependent, independent, and then also discrete or continuous is what's going to dictate how your analysis is going to be. And research questions usually dictates what variables you will collect data on. Okay, so that's kind of the take-home message that you should remember, if you don't remember anything else. Now this is the end of my lecture 2A. In our next lecture in 2B, we'll be talking about nature of data, and also related to variables. So we keep on relating, like I said, we keep on relating our previous concept with the new one, and then build the whole picture. It's like building a big house, where you have many different elements, different rooms, and construction. And the biostatistic architecture is really so interesting. If you really know and see all these elements fit into place and stick with each other, you'll be surprised how interesting that is and how elegant that is. So in lecture 1, we have heard briefly about how the nature of data dictates our data analysis decisions. So that's what we're going to discuss in my lecture 2. Thank you very much, and I look forward to seeing you click on my next lecture. Have a nice day.